Well, we've just finished the product rule, and now it's time to tackle the quotient rule. You may be familiar with the great sculptor, The Thinker, and in case you weren't sure what he was thinking, it was low d high minus high d low all over low squared. So I do want you to take a moment and copy down that saying. That is something we're going to use quite a bit. Low d high minus high d low all over low squared. And that's how we actually attempt our quotient rule. So you don't need to draw the picture, but please do copy down that saying. So our quotient rule is a quotient, of course, of two functions. Just like the product rule is a product of two functions, make sure you have two functions in terms of x. And here's how the product rule goes. Low d high, just like the thinker was saying. So my low is g of x. D high means the derivative of the high term minus high d low, derivative of the low term, all over low squared. Make sure you wrap that in parentheses and square it. Okay, so again, that saying was important. It wasn't just some goofy thing. We do use it to do the quotient rule. Low d high minus high d low all over low squared. Example 1. H of x equals x cubed plus 5x squared minus 3 divided by x squared plus 4. And our goal is to find h prime of x. So, do we have quotient rule? Are we dividing? Yes. And two functions in terms of x. Clearly we have x's on the top, x's on the bottom. So I'm going to need quotient rule. So I'm going to start with h prime of x equals, and use that saying, low, and just rewrite it, x squared plus 4, d high, derivative of the high term, so that's 3x squared plus 10x, minus high, x cubed plus 5x squared minus 3, d low is 2x, all over the low term squared. Now, one nice thing is we don't usually ever FOIL that bottom out, again, unless we can't find it in a multiple choice answer. We do, however, have to clean up the top. But your calculus part is over. The hard part that everyone thinks is hard, the calculus, is done. And now it's just cleaning up basic algebra. So you're just going to have to take your time. Clearly, you need to FOIL those terms out. So that gets me 3x to the 4th plus 10x cubed plus 12x squared plus 40x. Okay. Now, the ugly part, of course, is that second term. And I hope you can guess where everybody's mistakes are. It's usually in the subtracting. So when I do quotient rule, I do like to bracket this second part in because you're always going to have to make sure you watch the signs. So I'm actually going to multiply above and then distribute. So I get 2x to the 4th plus 10x cubed minus 6x. And now make sure you distribute that negative sign through. So I'm getting minus 2x to the 4th minus 10x cubed plus 6x. And that's our biggest mistake. And then we'll just clean up our like terms. So h prime of x equals, like I said, don't mess with the bottom. Just leave it as that quantity squared. The x to the fourth terms get me just x to the 4th. 10x cubed minus 10x cubed, that's gone, plus 12x squared plus 46x. And there you have it. So low d high minus high d low over low squared. Let's try another one. All right, number 2, do we need quotient rule or can we avoid it? Well, on top I have a function in terms of x divided by a function in terms of x. All right, so I got to go quotient rule. Derivative of y is y prime. Low d high. Derivative low is sine x, d high is just 2x, minus high, d low, the derivative of sine is cosine, all over low squared. Now notice where we put, well, I'll write it first and then we'll change it, low squared. Alright, so we'll just clean it up. I just want to be clear, when you multiply, this term has to come in front, it does not get multiplied in there. So this is read 2x sine x. This has to get distributive, of course. And again, I'm going to do it above and just watch my subtracting. So I'm going to get x squared cos x plus 3 cos x. And then I'm going to put that negative through. So minus x squared cos x minus 3 cos x. And what I was saying before is, watch where that squared goes. When you square a trig function, it always goes after the trig function. So sine squared x. And there you go, nice and easy. All right, now this one's significantly uglier, so take your time. Again, I have two functions in terms of x on the top and bottom, so I have to go quotient rule. Now read the top though. The numerator says 2x cubed times cos x. Notice it's this quantity times this quantity. So just notice that you have product rule inside the quotient rule. Well, let's go nice and slow. So f prime of x equals low d high, and that's where it's ugly, so I'm going to leave a space there, minus high d low all over low squared. Okay, so now I'm going to go back and take care of that ugly part. I have to take the derivative of the numerator. I'm going to bracket that in because we said we have product rule up there. So as I take that derivative, make sure you're saying product rule. First times the derivative of the second plus second times the derivative of the first. All right. Now again, the calculus part is over. It's just cleaning her up at this point that we need to take our time with. And I'm just going to clean up what I have inside that blue bracket. So I'm going to say that's really negative 2x cubed sine x plus 6x squared cos x. Minus, make that monomial term come in, I can multiply this and this term together. So minus 4x to the fourth cos x. Now, clearly at this point, you would just have to take the x squared and multiply it through, and the negative 7 and multiply it through. I'm going to leave it at that point. Hopefully your algebra skills are good enough to do that on your own. Next example, find the equation of the tangent line and normal line to the graph. So again, anytime you see line, remember you need a point and a slope. So my point, again, is the algebra. I know it's pi over 3. I just need to get the y value. So I have to evaluate f of pi over 3. So I get the sine of pi over 3 all over 3, pi over 3 minus 5. Pi over 3 is actually 60, and the sine of 60, don't forget, is radical 3 over 2, so that's why we need to know those trig functions. They just pop in all the time. All over pi minus 5. And if I clean that up so it's not a complex fraction, I'm just going to multiply the top and bottom terms by 2. I get radical 3 over 2 pi minus 10. Now, nobody said these were going to be pretty values, so just go with it. Now, lastly, I have to do calculus. That was, of course, just algebra to get the slope. So if I read that function, sine x over 3x minus 5, that's two functions in terms of x, I need quotient rule. So pause it, do the quotient rule on your own, and see if we get the same thing. Now notice, I'm not going to clean my quotient rule up because I'm just going to evaluate pi over 3. I need the slope when x is pi over 3. So 3 times pi over 3 is pi minus 5, and that's the cosine of pi over 3, minus the sine of pi over 3 times 3. All over 3 times pi over 3 is just pi minus 5 squared. So this really is not pretty. The cosine of 60 is 1/2. So I've got pi minus 5 over 2 minus the sine of 60 is radical 3 over 2 times 3 all over pi minus 5 squared. And again, I'm going to multiply everything by 2 to kill the fraction, and just make sure you do it to every term. So I get pi minus 5 minus 3 radical 3 all over 2 quantity pi minus 5 squared as my slope. Now, could it get uglier than that? I sure as heck hope not. So let's put it all together. The equation of my tangent line, so remember that's my beautiful looking slope, is going to be y minus radical 3 over 2 pi minus 10 equals this beautiful slope, y minus 5 minus 3 radical 3 all over 2 pi minus 5 squared times x minus pi over 3. And of course that was my tangent line. To get that normal line, just remember you're flipping and negating your slope. So my normal line is going to be the same thing, except my slope is going to be negative 2 pi minus 5 squared all over pi minus 5 minus 3 radical 3 times x minus pi over 3. Nobody promised that algebra would be pretty. All right, a couple more tonight. Find the equation of the tangent line at x equals 2 given the following table. All right, so again, I see the word line, I need an x, I need a y, and I need a slope. So let's do the non-calculus part first. I need the y value. So I'm going to substitute 2 into every x. And take my time. So f of 2 is equal to 2 squared is 4 times 3 is 12 times g of 2, which is negative 2, minus 14 over h of 2, which is negative 1. So that leaves me with negative 24 plus 14. I get a y value then of negative 10. So I know my point is 2, negative 10. Now I need to use calculus to get the slope. So again, I'm going to slow down and rewrite that function. 3x squared g of x minus 7x over h of x. Okay, and I'm really going to break it up using parentheses here. I would say this is 3x squared times g of x. So I have a function in terms of x times a function in terms of x. That's product rule. And I have 7x over h of x, so that's quotient rule. All right, so f prime of x is going to go first, derivative of the second, plus second, derivative of the first, minus, I'm going to use brackets for my quotient rule, low d high, h of x times 7, minus high d low, all over the low squared. Alright, so again, now we're just using that table and carefully evaluating 2, because I needed that slope at 2. So I've got 2 squared is 4 times 3, I've got 12 here. G prime of 2, I believe, is 3, plus G of 2 was negative 2, and 6 times 2 is 12, minus this lovely mess. I'm going to do the bottom first. H of 2 is negative 1, and negative 1 squared is 1. That's nice. H of negative 2 is negative 1 times negative 7 is going to make that negative 7, minus 7 times 2 is 14, and H prime of 2 is 4. All right, so just keep carefully cleaning up. I get, that's 36 minus 24, which of course is 12, minus 4 times 14 is 56, negative 7 minus 56 is negative 63, for a total of 75. So I would say the equation of this line was y plus 10 equals 75 times x minus 2. Whew. All right, avoid quotient rule if possible. So let me give you an example. Y equals x cubed plus 6x over 10. Now, nobody in their right mind should be doing quotient rule because remember, quotient rule is a function in terms of x divided by a function in terms of x. This is not in terms of x. So what do I mean? Well, I want you to rewrite this, and this will make your math and life a lot easier. What fraction are you actually staring at? I would say because that 10's on the bottom, I can pull that out as 1/10 x cubed plus 6x. Would you agree that's the same thing? Okay, so this time when I go to take the derivative, that 1/10 is just a coefficient, just leave it alone. And the derivative of the inside there is 3x squared plus 6. And it's that simple. So I'm avoiding quotient rule if possible. This is just a coefficient, and I just brought it out front like one. Let me show you another one. If I said y equals 4x cubed plus 6x squared minus x divided by x to the 5th. Okay, now you might be thinking, well, hold on, Mrs. Hill, this is a variable on top, variable on the bottom. You're right, and you are welcome to do quotient rule, but it's easier to avoid it by splitting. Remember, we've talked about when there's one term on the bottom, you can split. So watch how I rewrite this. I would say this is 4x to the negative second. 3 minus 5 is negative 2. Plus 6x to the negative 3 plus x to the negative 4. So I've done zero calculus. I'm just dividing each term. Remember, just be fair and do it to every term. Now watch how simple this derivative is. Negative 8x to the negative third minus 18x to the negative fourth minus 4x to the negative fifth. Okay, so avoid quotient rule if possible. Well, I think that does it for us tonight. Take your time and go back and rewind, replay anything you need to. Have a great night. We'll see you tomorrow.